out the mic, or should I turn this thing? Should I turn this on?
Yeah, that's
Okay. That banging noise isn't me, so 20 minutes, all right. Okay, so let's get into it. Okay, so where we go from here, this is kind of the overview of the afternoon discussion. And it more or less is going to be a bit of a kind of going from the high level, pretty down in the weeds with me and then coming back up. But Tony talked about collaboration scenarios and the role of tools in sort of organizing information and decision making. I'm going to get into the plumbing and talk a bit about really data and how it's organized and how that impacts the ways that people collaborate as individuals, as teams, but also around information. And then from there, that's kind of the segue into what we're doing kind of as an industry to develop data structures and data standards to make these kind of questions about data in exchange and interoperability work for the industry at large. And then Kimon is going to finish up with some really practical examples about how owners are taking advantage of these new data systems and data structures to really sort of integrate a whole bunch of information. So from an example of the owner, how this stuff works. So I hope that kind of arc makes sense. But again, we're going from the very high level down to some of the plumbing. And I would just say that I'm not exactly a computer scientist, but I know I can hum a few bars, and I've been around those people. And one of the goals that I will have for this session is to make this stuff the kind of systems and almost cognitive ways of organizing information accessible to you people. You don't have to be computer scientists, but you do use this stuff every day, and you are making decisions about big decisions about your firms, about what's possible, what the future looks like. And I just want to expose some of this stuff to you guys because you may not be working with it, but your 14-year-old children do know this stuff, and if they can sort it out, then at least you ought to be able to hum a few bars too. So data structures, just how information is organized, the way it's worked traditionally. We did have data before computers, and things worked. So I'm going to use that a bit just to talk about how things happened in the past as a segue to how they're happening now and how they're happening in the future, and then how we're redeveloping the ways that information is organized as we get to this explosion of connectivity of information and systems now that we have the web, what that means practically, what that means in terms of the kind of solutions to the kind of questions that were raised, how that's organizing, and then a little bit of an introduction to AEC specific data exchanges and standards, which will pave the way for what Roger's going to talk about, and then some example technologies. I'm also going to call an audible. Steve rightly said most people won't show up with a computer, but if you do have a computer, either a PC or Mac, probably not an iPod or iPad, if you want to open it up, I'm going to show you guys some links just to make this stuff a little bit tangible, okay? So let's just get into it as we go. So first of all, just as a high level, we're living and working in this connected world now. And there is this explosion of data, and somehow it all is interconnected. And so what I want to talk about is how the ways that information is put together so that it is navigatable, organizable to humans as well as computers, and then ultimately how we're going to use these new ways of managing tons and tons of information to map to either existing traditional AEC processes or ultimately new ones. So a good place to start is how we did it before. How did we work with information before computers? And this probably needs, do I need a show of hands who knows this diagram? Does it need explanation? Okay, so you should all know the bottom one, right? This is the kind of traditional, what's the one? Okay, it's very small. Okay, so on the bottom is the kind of traditional design, bid, build, organizational contracting structure, right, with the executive, the three parties at the top, the owner, architect, and general contractor, kind of leading the team. And then, there's a contractual decomposition or subdivision below that. So, of course, the consultants report in contractually to the executive architect, the general contractor manages subcontractors, and there are a bunch of other players. And then information and process moves kind of discretely from programming to schematic design, design development, et cetera. So you all should know this organization. Does anybody want to comment on this? I'm sort of perplexed why. This is not new, right? Okay, good. All right. So the point is that this was a way, and it still is a way of organizing complex processes. How? Any sort of comments on what do you see as an organizational structure? How does this help manage information? Any comments on that? Yes, sir. Oh.
Well, in some ways, humans are really good at solving problems when we break those problems down into smaller, discrete ones.
Yep.
And this does that pretty well.
Right. How else?
The relationship that all the architectural team reports to the architect, that all the construction reports to the general contractor, and at the same time, the architect in this case reports to the project manager. We actually call it the design manager,
Yep.
but it's the same thing. And the general contractor reports to the construction manager.
Right.
And then the program.
Yep. Great. Any other observations? There's a lot of things you don't see, like cross-dependencies between the MEP engineer and the MEP manufacturers, right? There's a lot of possible arrows that aren't on here, right? And, if I talk to a business executive, right, there's this notion that you have a certain kind of small number of people reporting to you. You don't have everybody in the planet talking to everybody. And of course they can, but there are sort of restrictions in how these boxes are connected, right? And hierarchies is a great, if very traditional way of doing that, right? Okay, so just to break that down a little bit, some of the salient features is there's this notion of discrete objects and relations, right? I mean, you can see these as these objects in this case are entities, right? But there's a relationship between the architect and the owner, an architect and its consultants. There's a relationship, implicit or explicit, between the owner and the general contractor, right? These are discrete processes and exchanges between those processes or organizations, right? There's also this notion of internal versus external behavior. So inside the architect's work, things can be very free-flowing. They can be highly unstructured. You can do a bunch of studies, a bunch of napkin sketches, have a conversation, throw it away, start over. But then between organizations, things are highly structured, right? You need contracts, you need standards, you need, RFI forms, you need all kinds of stuff that restricts the ways that people work across these boxes. And then in a tech speak world, that's known as having a, quote, small pipe, right? Very large pipes inside the organization, very unstructured, but once you get between different organizations, things are throttled right down so that, again, you can't just like willy-nilly go, engineer is a great idea. He doesn't just call up the fabricator and say, hey, why don't you build this? It has to go through this structured process, right? And then hierarchically organized. And I'm going to focus on that for about 10 minutes because it was the way that everything was organized in the past, right? And again, if you're a management consultant to a business, the answer, you go and talk to an executive, how are you doing, how's it going? Well, how many people do you have reporting to? Oh, 12, well, that's probably too many. You probably only want 5. I mean, something that mundane. Those are the kind of the high-level ways that we structured information in the past to just make this stuff work. Okay, so dividing and conquering the problem, generating information over here, generating, products and installing them over here, limited visibility and control at every level. That's how things worked in the past. So, sounding more familiar now? Okay, good. Some people not. Okay, so coincidentally, this is the basis for all modern computer systems as well. And I guess when I say modern, focus on late 20th century and maybe the early 21st century, but things are moving from that. But this idea about a hierarchical decomposition of a problem is the basis of a lot of computer science before let's say, the new millennium. And all of these other things, objects and relations, packaging, small pipes, internal versus external behavior, that's basically the 20th century of computer science writ large. Okay, so what has changed? Now we're moving in some ways from from a prior to BIM world to this building information modeling world, and a lot of what people assume when they talk about BIM, and I think you guys are more sophisticated than that, is that, oh yeah, we're moving from 2D to 3D, right? Okay, and that does change a lot, but again, there's a lot of data, a lot of data systems thought going on behind that. And the first one is that we are moving from symbolic information to this idea of objects and relations. So if I draw, 4 lines in an arc on a floor plan, as a human, that's a door. But as a BIM object, we all know we need much more than just that graphical representation. We actually can, create intelligence around that door, package it, put some interesting stuff in that object, and then as it connects to other things, we can get that information out. So the corollary to that is we're moving from systems that require a lot of human transcription. If you're moving from a plan to a section, in the good old days, you needed to pull up your Mayline or your CAD system. And of course, we know now that BIM at least has the possibility of moving from the 3D model to a 2D plan, to a section, to a schedule, right? And computers can do that traversal between different representations of the overall structure. You can also, with some capability now, move between an engineering view and a fabrication view, right? So this idea of being able to move information autonomously from one system to another, I think that's part of BIM, and it relies on this idea of, first of all, you need a single 3D object, not a collection of lines when you describe something. And then you need this idea of the door as a specific object, not just as a collection of stuff that that you need humans and smart things to do that traversal. The other thing that happens is now that we have this idea about these objects and their relations, we're talking about a ton of these objects and a ton of these relations. So we're not just talking about geometry or spatial relations, we're also talking about metadata. Do people know that term, metadata? Show of hands, please. Okay, yeah, so metadata is the information that is non-geometric, that hangs on these systems, that actually is, in many times, as valuable as the 3D information itself. People are talking about the parametric logic. I'll talk about that in a second. There are documents that go along with this, so you do want to be able to tie your word specs to your BIM object, etc., and you want to be able to do that through linking. So we're now faced with this constellation of federated information, multiple representations, multiple sort of packagings, and ultimately there is a continuum across all of this information, right? That's the problem that we're faced with now. So how do we handle this? Well, at a first level, the answer is we just use more hierarchies for this information. And here is an example, right? I've got 3 hierarchies up here, or 3 ways of structuring. Let's just talk about metadata right now. I can think about data as being uniformat, master format, schedule data. I guess if we could do an exercise and just talk about all the different types of data that's being hung on this stuff. But the first thing that you notice is that, again, every one of these organizations in some level is hierarchical, right? So if I just look at a simple thing like the uniformat numbering system, it's got this numbering convention that is hierarchical. It's not a random number. The B20s, encapsulate all sorts of exterior enclosure, and then there are sub-flavors of that, exterior walls, etc. So even though we're just talking about one piece of information, we can start thinking of that as a way of dividing and conquering that specific view of the world. Same thing for master format, right? The different divisions, those also have hierarchies. If you look at a schedule, of course that has a hierarchy of it, construction versus concrete versus carpentry, right? We're using the same ways of dividing and conquering information. We're just doing a lot more of it, right? So that's the first step. The second thing that you notice, though, is that there is some mapping across these. So, and this begins to trip things up pretty quickly because, and this is a bugaboo for these particular data standards, right? Because, and how many of you, well, I think this is also known by many of you, right? The ways that systems and even BIM objects are organized in uniformat isn't one-to-one with the way systems are organized in master format, right? your wood products, your wood systems are actually all over the place, right? Different assemblies, the wall systems and door systems and furniture all have wood products, or can. So the mapping between these isn't always one-to-one, right? Same thing for schedule. Does that make sense, right? So we've at one level, we're just taking the same structures and using that to structure richer and richer metadata ways of looking at things. At another level, we've got to now deal with the kind of idiosyncrasies across these ways of organizing information. 6 minutes. All right, I got to keep moving.
Yep.
How much did I get so far? 14?
Yep.
Okay. All right, well, let's keep going. Okay, so, all right. So I just want to kind of point out one sort of conceptual way of thinking about this. And the goal is to actually use this hierarchical system information to organize across these data structures, and in some ways kind of come up with alignments between different decompositions that, quite frankly, that are aligned. And one of the takeaways is that projects run well when there is an organizational alignment across different data systems. When your work breakdown structure and your contractual breakdown structure and your drawing breakdown structure are all in some senses aligned, right? The other takeaway is that things fail when there are at the connection and when there are misalignments between these, right? If one entity has to manage across two drawings, where do errors happen? They happen between systems and they happen between drawings, right? So organizing your project and being very observant about the way your information and your team organization, your breakdown of work are aligned, that's a big piece of how we organize information. I think I'm going to kind of skip ahead in the interest of time. Tony mentioned this idea of extreme collaboration. I just want to kind of very quickly go through an example of that. And that really is this idea of how these large manufactured systems are organized. And suffice to say, again, in the late 20th and early 21st century, everything was organized around this idea of hierarchical decomposition. And in the manufacturing industries, they call that configuration management. And the idea behind this is that if you look at something like the Boeing 777 program, you're not just designing, unlike buildings, you're not designing one airplane at a time. You're designing the entire fleet and the entire possibility of Boeing 777s with a common set of data organization. So it looks a little bit like this, and I'm trivializing it a bit, but you have this very simple, in the mechanical world, a very simple idea of decomposing a product into consistent systems, subsystems, like the propulsion system, the fuselage, the wings and the lift systems, and then those things decompose further, right? And this is an extremely powerful way of managing, engineered programs. And so just to kind of, and so when you look at different, so then there are these kind of light dependencies across the different organizations, and then you can expand these things out. So very simply, you can have a propulsion system that's a 2-engine configuration or a 4-engine configuration, and really you can manage both of these as a kind of concurrent engineering problem. So that's how the aerospace industries, who had the advantage of scale and economies of scale and quite frankly a lot more engineering dollars per program, that's how they managed this stuff in the 20th century. I just want to kind of point to an example of how that was done again, the late 20th and the early first decade of the 21st century. I worked with Frank Gehry and Gehry Technologies until quite recently, and suffice to say, we used those technologies to manage the development of these really complex programs. And without going into the details too much, this is this idea of the hierarchical decomposition of a project with associated stakeholders that manage those pieces. And again, at some level, we're just sort of decomposing a very complex building into different systems, the primary concrete, the secondary systems, the MEP, et cetera. This is what you do now with products like Revit and others, but implicitly, using things like drawing management and model management as a way of kind of organizing and distributing work. So here are the cross-system dependencies, where you're looking at specific subsets, like in this case, the auditorium, which will have, of course, structural and mechanical and environmental systems kind of pulled together, but it's overall driven by this top-level hierarchy. I'm going to skip through most of this, but then once you do that, you have this ability to now throw in parametric objects that are plugged into this hierarchy and accept inputs from the higher level. So if I have this exterior envelope surface and I have a structural frame, I can start plugging in intelligent objects, equivalent to families in the Revit vernacular. And these objects can be responsive to their input conditions, so they can adjust themselves. And then when the overall top-level hierarchy changes, these job objects can adjust themselves. So that's kind of how we're working with these information systems today in the building information modeling world. Once you do that, you can deploy and use automation to develop vast levels of this stuff just by, again, populating these systems and their high-level organization with these intelligent objects in the right places. So, and that was sort of a segue for us, because in order to manage this across, a globally distributed team, we needed back-end technologies to help us manage that. So when you're working around the clock, if I upload my high-level model, that's going to get downloaded somewhere else, and those changes are going to be populated, and then we have to, handle that information in the context of other stuff as well. So suffice to say that we're now moving from this world of interrelated, semi-compatible files to a world of interrelated, semi-compatible, web-based information. And that motion has been going on for a long time, and there's been a lot of promise around that, but I think we're starting to see that, that ability now to take off in the industry, where those BIM objects and the other associated objects can now go into web-connected systems that allow other stuff to happen with them. So suffice it to say that I think this idea of sort of continuously connected, always-on information, at some ways makes things much more complicated, because all of this stuff is chattering with each other. But at another level, because it's always on and always connected, we don't have this idea of these kind of discrete silos of information that get exchanged and coordinated once a month. It's, we have to deal with the fact that this information has to work across these different boundaries on a continuous basis. So I think we're going to see this resolve some of the tough remaining issues that have been sort of, plaguing this interoperability world for a long time. Pretty close to that.
2 minutes, yeah.
Okay, all right. So, so again, we're moving from this idea of this hierarchical, discrete, limited connectivity world to this explosive world of connected data, connected people and physical assets, and systems that manage those connectivity. And of course, surprise is you're working with those kind of systems already. So under the hood of something like Facebook is a vast, there's a vast amount of information, but if my grandmother pulls up Facebook, she only sees the stuff that she cares about. So managing these kind of networks of information in a controlled way, that's where we are moving, as an information sciences industry, and also as a collaborative AEC industry, and I think that will be kind of the tee up for what, for certainly what Kimon's going to talk about and what Roger will talk about as well. But suffice to say that, from my world as a Facebook user, I see the information, only the information that I care about, and it's in some ways much simpler than how things looked in the past. So this idea that I can sort of understand this vast connected world of data as a localized problem, only seeing it from the lens of what I care about and, and stuff that's directly related to me. A lot of these systems are evolving in that way to use the advantage of, web services, connected data, to actually simplify the way the world looks and to take care of the complexity and obscure it and just show you what you're interested in. The other thing that I would point out is that, these products, to the gentleman's point, they actually play nicely in a very sort of what can I say, a very simplified way. So, of course, Google and Facebook at some point, at some level, are arch competitors, but you can easily plug a YouTube video into your Facebook page without knowing anything about what happens behind that. So these systems take care of the fact that you have not just federated, tons of federated data that has to work together, but actually different applications that plug into each other. So I think I'll kind of, we're starting to see tons of these connected systems. All the different vendors are starting to move to the cloud, and they're all starting to adopt some of the kind of the web strategies that we'll talk about in a second to make these systems play nicely at one level with each other. And maybe I'll just kind of, in my last couple of minutes, talk about one example of this. Also, we are, the other things that I would kind of point out and that my organization is really interested in is how does BIM scale up and scale down? And so now that we have these kind of very rich data models that are somehow connected to, they're out in data stores on the cloud, we can pull those together and mix and match them. We can start scaling BIM up to, increasing it to the campus level, to the city level. The kind of divide between things like GIS and smart city data and smart building data is starting to converge. And at the lower level, we're starting to have these kind of sensors and small intelligent devices kind of scattered through buildings that we can start connecting to as well. And I think I'm going to just close this with one example. I was going to show about a couple more examples, but maybe we'll have time later. I just wanted to show you one example of one of these systems. So this isn't a building app. This is actually a smart city application. So MARTA is the public transit system in Atlanta. We've been tying their information. This is actually a view of New York City, which in some ways has a little bit of BIM data already connected to it, not very much. I'm just going to flash up another viewer. This is the Autodesk, I'm not supposed to say products, but what the heck. This is their new Fusion viewer, I think it's called, is that right? Forge viewer, yeah. And you'll see kind of some of the data that we'll show you in a little bit, but these ideas of object IDs, some of the metadata, etc., these are being accessible both through viewers, but also in the same way through these data services. So I just wanted to pull one of these up that we've been doing a lot with. This is MARTA's API for bus information. And you'll see this web link. Oh, I'm sorry. Oh, shoot. She told me this before. Okay, so you didn't see any of this. So again, this is a public and open source, kind of like a Google Earth that has some BIM data already integrated with it. It's actually city GML data. I think somebody mentioned that as well. So we're starting to converge this city level view of data. This is managed by the City of New York as a publicly available database of all of the buildings in New York. So if you look up New York City Department of Information Technology City GML, you can actually get to this data set. This is called the Cesium viewer, which is an open source viewer that can accept that information. Here is the Autodesk Forge viewer of a specific building. If you can go to lmv.rocks and get this yourself. If I click on these objects, I'll start getting this metadata out of these individual kind of discrete objects. But then I can also pull up an API on the web. And let's see, what's that one? Let's see. The MARTA API. So I'll just pull up the MARTA API. Okay. So this is just a really quick view of the kind of stuff that people are making available now. So this is this transit system of Atlanta. They provide an open API, and that application programming interface is a fancy way of saying, a way of asking for data and connecting it in human and machine readable view. But the same sort of protocols work for both humans and machines. And I think Roger will show you some examples of that. If I just go take this URL and just paste it in here, this is the Get All Bus API. Okay, and it's a little bit hard to read in this viewer, but this shows basically, let's pull up one of them. This is a specific bus. This is the location of every bus in the city of Atlanta. So here is just some of the information, the route number, the actual name of the location where it is, the location of where the bus is, the vehicle number. You'll actually see somewhere the longitude and latitude of that exact bus. It shows that it's going southbound, etc. This is just one example, and while this is a little bit opaque, I want to just make sure this is something that actually you can, there's views, you can put this on a map, and people do put this on a map, but these kind of web services are available for all kinds of data, and all of that data is increasingly being available through the same sort of technologies that humans use to get to this information, these sort of web links and the associated APIs. So with that in mind, I think we're going to turn over to...
We're going to take a break.
Oh, we're going to take a break.
Yeah.
Okay.
Yeah. So thank you. Let's give Dennis a hand. We will have more time. Just take a 10-minute break if we can to try get back on schedule. But thank you, and we'll have more time to talk about a lot of this at our final panel discussion. Good job. Sure, yes, absolutely.
So, I used to work
Coffee, anybody?
Yeah.
Go grab a cup. Steve?
Just black.
Black? Dennis?
No. Oh, actually, yes.
Yes?
and that it's actually bringing closer. That is not as much part of the relationship.
There you go.
Certainly allows those that want to update and those that architects firms who are using to expand the relationship around the Gensers they're starting to kind of manage, their goal is to manage space for clients across multiple projects. They don't want to have project rush, they want to when you need a renovation, so you don't shop it up on that space, right? And I think they are starting to use data master that that kind of, once you know their color standards and you have kind of render templates built in, and you're holding your information to the proper part. And that's just one example.
But that's true for their side. They all do
Yeah.
they have a certain. In other words, if you're on color,
Yeah.
I
I think that's true at this point. Yeah. I mean, if you want Frank, you used to get the whole process.
You know,
I think it's also, yeah.
But that information. More recent work seems to me to be moving away from going back to, in a way, I see it. I have
Yeah.
a early house,
Right, right.
kind of simple moves, but without so much of the. I don't know if that's just
No, I
his
think.
emotional state or whether that's because he sees that. Yeah.
We did the hard stuff. Now
Right.
the question is, can you do this and feed apply the same thing?
Well, what's kind of interesting is in the show that was at Blackmore, you saw the early days, which I was, and then you see it moving into the back and all the stuff. And then you see kind of a post-digital, I would almost call it post-digital, where it's work that obviously still uses digital technology, but it doesn't show off the work.
Yeah, it's not doing gymnastics.
Right.
Yeah, and I think that's part of the question is, you can't use the same
They're very influenced by how we doing? The Zaha Schumann, who I think is a total, I mean, how are you?
I think I'm not allowed to comment. You go through with the client. We did a lot of it. So GT did a lot of it. Yeah.
That's a long.
Yeah.
It's unfair.
I
Hold that out.
But I do think, I guess I'll just continue. I think that there is this idea that there's a level of control that architects can assert through technology.
They could.
Yeah.
And I think he was successful.
Yeah.
But I don't know if that can be applied, accepting this huge
I'm an optimist. Yesterday's I lost.
But let's do let's do one before Roger and then after.
I have a slide of this.
Yeah, I mean, do we want to do two or three?
Every student.
Okay. No, I mean, the feedback from people is pretty positive.
Yeah, I think in the theme,
You have an intravenous line that comes with it?
Wait, let's put them down.
Thank you.
Some are,
Black?
I think this one's mine.
Thank you. So Roger, you have 8 minutes.
Are we way behind? How much time do I have? Are you going to keep track?
I mean, I keep track of it.
8 minutes to start, before we start.
8 minutes total. No,
But give me,
no, we're taking
I
time.
need some cues because I'll get on track.
To take advantage from that.
So, do I have
He's done-
20 minutes? Am I supposed to talk in 20 minutes?
I had to stop the recording. Because the guy said, is anybody recording?
Oh, yeah.
Oh, somebody
Tony,
said that?
Tony said, this isn't being recorded.
I can stop the recording.
Well, Tony said, this isn't being, you can say anything you want, this isn't being recorded.
Oh. So you
Tony said
you
you
still
didn't
have
say
25
Tony
minutes. But we do have to roll.
All right, that was good. Good setup. All for everything? Well, but Dennis gets, well, I don't know, he used up his extra time anyway. He moved some of his Kobe stuff to later.
Was Dennis listening to those?
There was a couple of slides.
He was gonna add. He's coming back.
Kobe's important.
No, we don't. We have, we're running out of time. Well, that's true. Okay, so we are on. So we should be at 3:10, is that what time?
Oh, this one is automatic.
What do you want to do? When do I?
You start at 3, yeah, you still have 25 minutes, but what is this?
Nobody's using this, are they? Roger presents and I have a second. That's why you see.
So the workshop, you just come on up with this.
Well, the workshop's in your schedule, in your presentation.
Yeah, no, there's two workshops, one after Roger and one after. Dennis was listening.
You're gonna have to be ordered.
What was he gonna say?
He has a few shows.
No, we don't want to. You're such a politically.
Challenge.
Are you in line with the rest of your family? Are you not?
I can't answer that. I own a media company. I cannot be. Actually, I don't own it, but.
You go to the side.
Nixon?
Well, you're very happy because you got a tax break today.
So there's errors.
What did you do? 7%?
No, it wasn't. Everyone's talking about now it's 30, maximum, that's what I just said. Maximum for a personal rate is 35%. That doesn't make any difference to me. That's only for the wealthy. It's reducing the tax. Oh, you do? Well, but 35 won't help you.
If you want to see that income from the company, so you really prove the sole.
Right, exactly. Okay,
It crushes it.
I'm gonna go through mine. Except for that. Except for that. I'll forget a bunch of stuff too.
just forget.
At least he's honest. What did I say? I don't know. I forgot half of it.
Does this clicker work? The laser pointer doesn't work?
Well, the laser, it's such a big bright screen. I don't know if this is any.
So do you want me to show you how great the auto? So they finally. Notice which one.
I can't handle two devices. That's for sure.
It doesn't film there. That's one. That's what they did. Yeah, so fucking. I'm just really pissed off. Who, anybody going to the knowledge community thing? Did you guys sign up? Yeah. You going?
I didn't sign up. So you have to sign up? You sign up, pay in advance?
It's 35, yeah, you can pay at the door, you can maybe, I slipped Roger in last time. Okay, that's,
This one mine?
Straight black? I think so.
what's that?
This is my copy?
We have the slides that in it.
Did you take my little
I probably did.
USB file? I just wanted to, if you have it. If you don't.
Well, I was gonna, let me just see.
If you can, it's great. Okay, couple other questions here for everyone as we reconvene. Has everyone filled out the sign-in sheet?
We'll need you for first session to get that.
Yeah, you're still in the first session. Anyone fill out the sign-in sheet? Got it. Okay, we're going to get started again, everyone. And don't leave, because we have giveaways at the end. We have a cruise. No, we don't have a cruise. No, we don't have a cruise. Sorry. The BIM cruise. Okay, yeah. The sailboat, yeah, my sailboat. Okay, so with that, we're going to get started. I know a few people come in, but Roger Grant is here with us from National Institute of Building Sciences. So with that, let's get started, and we'll try to stay on track. Thank you.
All right, thanks, Steve. Hello, everyone. And I'm, Steve said, Roger Grant, National Institute of Building Sciences. I'm going to talk about standards and innovation and how to, I hope, find a pathway to achieve some of the vision about innovation and technology and how do we make it work for us. And I suppose some of this is, you file it under the category of things I need to know about but I'm not going to deal with directly, and some of it you file under the category of things that I need to know about and I should be dealing with directly. Partly it's about things that we can do to make our work process better, and partly it's about the things that we need the industry to do, and by the industry I mean not just our profession as designers, but also our clients and the companies that provide tools and services to us. So I think all these things work together. This is the definition for BIM from the National BIM Standard, and I think it's powerful because it highlights this idea of facility as physical and functional characteristics, and it's about the information that we use across the life cycle from inception onward. So that's really, the physical facility is a place for us to use and manage all this information, but it's not just about the three-dimensional model, and I think we all get that, but it's about spreadsheets, it's about other kinds of software, it's about databases that hold a lot of information in them, it's about legacy systems that building owners have for energy for energy data, or for all kinds of information about their staffing and their space requirements, for example. The model is just a place for us to connect those things to a physical representation of the building. Kimon showed these earlier about the transformation in the handheld communications devices, where we can go from one metaphor to one where we can plug and play all these applications, and it's happening because of standards in the background. And those standards really create competition. That's the real value of a standard. It makes for competitiveness because the playing field gets leveled and people can develop off of a common baseline. In the building space, we have the challenge, pointing at the screen, that's not such, okay, there we go. In the building space, we have the challenge of trying to integrate together all these kinds of information and have this model of generating these applications that can work with it, things that can do, of course, modeling, but we've been talking about a lot of these innovative technologies. And the middle of this is standards that we use. Now, there's different kinds of standards. There's standards for how we exchange data. Dennis showed some, how do we go to an API and get data about that's posted using XML or JSON. Those are kinds of data formatting standards. But there's also standards that organize information together, like COBE and IFC, that give a structure, a schema to data that take some time to put together and make these things work. So what I want to talk a little bit about is how that process happens, and then what you can do with it. An example, a couple examples. Challenge is that in the building space, I know I don't want to pick on Dennis, but he referred to Facebook and about how all the power of what's behind the scenes between relating people together. I think you could argue that we have a more complex problem in the built environment world, where we want to be able to go from the very lowest level of a component in a building to the global depiction of the world and how everything fits together. And all these things are interconnected in some way or another, and we can certainly see big data, GIS, going down into building models, CGML, how we want these things to all work together so we can take advantage of that connectedness. At the building level, it's the same kind of going down a level lower. We have the idea that we have a model, and it kind of got blocked off there, but inside that model, there's a lot of different components and pieces and parts. And what if we want to know about the 52 doors that are in this building? We would like to be able to find those out of that building model and see data about them, like properties, and how those properties can be found and described in a consistent way, and how we can then take that and connect it to other kinds of information, like specifications. We've talked about that a little bit, like cost estimates. All these things, these doors are described by all these different pieces of information that are in other systems on web pages. So if we have a structure, we can identify how those things can be connected together, but we need some kind of a structure, and establishing that structure is where the work that we do to try and make standards that allow that to happen. So with standards, we can make this data that is machine readable and shareable, and we can get good data, which is important, that we can traverse. We can certainly find lots of information, but if we can't understand the structure of the information and the data, we can't really make use of it. So it has to be organized in a way that we can work with, and we have to also be able to deal with lots of legacy information. We're not going to get people to reorganize all their databases to a nice new structure. We have to be able to make use of it in its current form, but use it efficiently to make decisions, to do design work, to do construction operations. And what we need to be able to do that, I would contend, is a good set of standards that are openly available. And those need to be open standards. They need to be publicly available. They need to be shareable through some kind of licensing arrangement that makes them work. I mean, that's what the internet is based on, is open standards that are published that everyone can use to get information exchanged. Has to be publicly available, and the internet's a good example of that. In fact, since we're here, I dug this out. AIA made this statement in 2009 that software must support non-proprietary open standards, and this is best accomplished through professional adoption of open standards. So AIA thought this was a good approach. So where I work on open standards, and where I think in the building industry we have the chance to do this, is through an organization called Building Smart International. Building Smart International it has chapters in 18 countries. Its idea is to help with these processes, to help with standards across the design, procure, assemble, and operate that are open and neutral, and it helps to support open building information modeling. By open, we mean it's non-proprietary. I think someone talked about this earlier. We want to be able to generate a model in one system, but use the data in another system. We were talking about communications and the challenges of how do you, people use all these different collaboration systems. Well, if we had a good open standard for how you should collaborate, we could exchange the data from one collaboration management system to another collaboration management system. We wouldn't be locked down to the system. It's particularly important for owners because they need to own their data. You don't want it to be locked up inside an application. So I think this is probably intuitive, but the point is this is important, especially for owners. So Building Smart accomplished this through these different standards that they've developed. First of all, before you came here today, have you all heard of Building Smart International? Okay, thank you, Tony. How about IFC? When I say IFC, does that mean something to anybody? Does somebody not know what IFC is? It's okay, you don't have to be, like who said, well, anyway, it's okay if you don't know. But, because I'm going to tell you, IFC is a data model for identifying information about buildings and infrastructure. It's a schema, basically, for how do you structure together how the different pieces and parts, components of an asset behave and interrelate with each other. And it has a syntax for how you exchange information about those pieces and parts. And it has a comprehensive specification that tells you how all that works. So that's IFC, Industry Foundation Class, or Information for Construction model. It's the core model of Building Smart. Building Smart also has ways of modeling processes like IDM, model view definitions, and exchange requirements. And this is meant to say that we have this big model that tells how all the different pieces and parts of a building, or increasingly now of infrastructure, we're doing a lot of work with bridges, road, and rail, and how those components fit together. And the process modeling tells us at this point in time, when we want to exchange information about this process, at this stage, what information do we need to know based on the open standard that describes how everything fits together. And it's a way to make a mapping that relates to a use case, for example, and it provides a specification that software can then be developed around. So, you know, we've talked about how well are we doing in technology adoption and use, and where are we with using BIM, and I think we do pretty well with how to operate the tools. Where we fall down is how do we exchange the information between processes and procedures, and that's where I think we still have quite a bit of work to do, and these standards are ways to help us do that and give the software vendors the requirements so they can build their tools to meet the requirements. And then the third area of standardization in Building Smart is around terminology. We have this system called the Building Smart Data Dictionary that's based on an ISO standard for how do you identify objects in models. And it's a way to have unique identifiers for properties and objects, and using the IFC model, extend that into other kinds of data sets. You know, the IFC maybe covers, I don't know, several thousand objects, 7,000 or 8,000 objects, but there's you know, many more times objects than that, and many different properties. We were looking at HVAC equipment recently, trying to do models for product data, and we were able to model for this heating element. We were able to identify in IFC about 40% of the objects and properties, and 60% were not in the IFC model. So when we get out into the world and talk about specific products, there's a lot of different complexities we need to manage, and this dictionary is a way to agree on the common names of classes and objects and be able to share those and not reuse them. And you know, we're trying to solve this problem in buildings. We've talked about aerospace quite a bit and how, you know, they've been able to use modeling more efficiently because they're a pretty consolidated industry. We're very fragmented in the building industry. We don't have the consolidation of power, or even less so here in the US. We don't have one central building agency to mandate how we are going to do things. So we need ways to work together that are collaborative and allow us to share. So we have to have some standard ways of doing those things. And there's also a collaboration format within Building Smart, the building collaboration format, a way for adding messaging to models and having RFIs and RFCs in a consistent way. So that's what the core standards of Building Smart are. Building Smart has 18 chapters across the world, so we get to take advantage of what's going on across the world. In the U.S., we, just to point this out, we have a little issue going on with our chapter structure here. The chapter was at the Building Smart Alliance, which was at my organization, National Institute of Building Sciences. There were some disagreements between Building Smart Alliance and Building Smart International, and the U.S. chapter is now, the U.S. chapter of Building Smart International is now at the BIM Forum. My hope is that these organizations will come together and figure out how to give us some kind of a integrated chapter in the U.S. that takes advantage of all the work that's been done at the Building Smart Alliance and create something we can work together on here. So anyway, that's the current status of the U.S. chapter of Building Smart. But Building Smart's really an international organization. There's a lot of big companies participating in it increasingly. In Europe, there's a lot of interest in activity and standardization of building information and how it can be exchanged and used across the whole facility life cycle. These are some big organizations that are members of Building Smart, and there's also a number of other organizations that are sponsors. So some of these are like Reich Waterstaat, Traffic Verket. These are infrastructure organizations, railway operators in Europe, road and bridge operators and owners. That's an increasingly important area within Building Smart. A lot of some information companies, our friends from the UK, Reba, are members of Building Smart and participate in the data dictionary work that we do. So there's a number of organizations working on these problems around the world, and also Building Smart collaborates with a lot of standards bodies, ISO, SEN for European standards, OGC, and ATIM is a classification system that's used in Europe, and also with some different programs that are going on. Building Smart's really about, I don't know, this slide is ability. It's about users, standards, and compliance, and trying to do outreach and develop these standards that are based on what industry needs, and then have a way to test and determine compliance. There's a compliance testing process for it, and working with the different areas, building, infrastructure, product, technical, and also now we're getting this some airport room, a construction room. Infrastructure has been growing quite a bit, and how to work with software, people, process, and models. So this is from our recent summit in Barcelona, which was the largest attended event that Building Smart's had. And some of the things that came out of that summit were, there's some projects that are really making use of IFC-based models. Schiphol Airport has a project that they went through. They did everything following all of the standards. They had a process mapping exercise to determine what uses they wanted to meet. They went through and expressed all the requirements in IFC. This is an example of a hospital in Austria that required everything to be submitted, all their models to be submitted in IFC. So there's quite a bit of progress in Europe around in building space on modeling. Big building product manufacturer Lafarge Holcim has just gotten involved. They're very interested in how do they organize product data. One thing that's going on in Europe that I think is going to affect us a lot here are these common European standards that are that exist for all the countries that do business in the EU, and they are working on a standard now to require the use of all the Building Smart standards as part of common European standards, which will drive adoption across Europe, I think, and push those standards out into other parts of the world. Yes, Richard?
We've actually just adopted a number of the Building Smart standards as full European standards.
And you're chair of that committee, the strategy committee, right? Yeah, one of the working groups. So this is a big development, and we're actually working on a product data template standard for Building Smart. There's a lot of interest in, and it's been, we've been trying to do this here in the U.S. too, get product data that can plug right into meet the requirements of the model. But the issue is there are all these different modeling formats, but based on software. And what we want to do this is a common way using IFC. So we're working on this standard right now and publishing it, and it's going to be adopted by the SEN committee And, you know, that's what these big product manufacturers want, because they only want to do this once and do it in a consistent way across the world. This was from a presentation from the Rail Commission of Northern Europe, and you know, they looked at all their things. They're trying to figure out how to use building smart standards. They found out in looking at their maturity that the area of standardization was the weakest area that they had, so they were trying to figure out how to set up standards they could use to collaborate across their infrastructure. And interestingly, in my little world, I work in the product data part of Building Smart, but in Austria, there was a move to make a countrywide property server. There's more of these countrywide initiatives like Richard described this morning, such as is going on in the UK and other European countries. And they made a server to have a standard set of names of objects and properties that everyone that does that submits models for the Austrian government to meet their requirements could use. So this guy we work with built a server to do all this stuff, and Autodesk, and now he's got a little plug-in that sits inside of Revit. I'm going to just say that proprietary name anyway, that can allow you to map Revit families to IFC and to extensions of IFC, which is, I think, an interesting development for how we can align tools. Because a lot of what we do is not about the geometry, it's about all this data that exists in databases, in extensions, in product data, in the system for tracking spaces or tracking equipment inside buildings. So being able to have the model and have an open representation of it, but extend all kinds of data on it is really important. So those are just a few things that came up at the summit. What we're trying to do is figure out how do we capture data in a digital format that's useful so we can automate all the tasks that depend on it, make better decisions, and spend less time on non-value added tasks. So that's kind of, other people have said this, it's just my way of saying it, I guess. Interestingly, one of the big software vendors agrees with this. This is from Autodesk. All these products support IFC, and this statement from their website says that they believe that open standards are the way to provide and share information. So how do we work with this? And now this is where maybe I'll go through this quickly because it probably gets a little detailed, and Steve's holding up his hand for some reason. Hi, Steve. So the idea is, how can we have workflows that are reproducible, that let us capture these structured ways of working? Because I think the big problems we have are because we haven't organized the exchange of information clearly and expressed what the requirements are. And so if we use Building Smart's tools, we can go from a process model view, use the IFC model to establish requirements and say specifically what those are in a way that ties to a particular use, have a collection of the data, the types of data that we're using in that exchange, and establish what that is so we can manage it, and then be able to let multiple pieces of software access this information and make their software work in the way that it's required to work to meet any particular example. And this happens to be based on, I think, an example that we did for bridges, but it's really kind of a generic workflow. So we had a project for Federal Highway where we were able to develop for bridges a way to use a standard process for modeling bridges, that we developed this complete process map, which is an information delivery manual based on IFC, to say, what are all the exchanges that need to happen of information across the project lifecycle? And what we really care about is establishing those exchanges clearly so we can document the requirements. And in that way, I think somebody else said this, Dennis mentioned, when you get down to an exchange, you have to have a really small pipe. You have to be real clear about what you want. So we did this for design to construction contract exchange for bridges, and we were able to use the model view definition tool to write exchange requirements. we used 2 example bridges as a way to specifically establish the requirements, and then we tested it in software, and so this was generated, I think one of these comes out of Revit, another one comes out of Tekla. We could take those general files made from capturing those drawings in IFC and use the tools available today to do this for bridges. And we're working now with AASHTO and Federal Highway to move this to a standard here in the U.S., which I think would be a big breakthrough if we're able to do this for how do we standardize exchanges. And so, you know, in the building side, we made a comprehensive process map for bridges here, which is an important way to identify what data, who needs what data when, and how do you organize it for exchange. And right now, Building Smart Alliance is working on a process map for the building space, which goes across the whole building space and identifies at different levels what are the exchanges, and I should have seen it over here so I can point at the right thing. What are the exchanges, and what exchanges have we already documented? So for example, I know we're all real aware of COBE, which is a way to hand over information from design, from the end of construction to the start of facility. And that's just one exchange. We've done some other ones for fabrication, like with precast concrete and structural steel. GSA has a space validation exchange documented. So capturing this all in one place is important. This is something you could get involved with at Building Smart Alliance. And this is, I think, you know, we've all tried to work with COBE. We're going to talk, if we have time, a little bit more about COBE after we do a test case here. But you know, COBE is just a big way of looking at the IFC model sorted out into a spreadsheet and telling you what's everything you might need to exchange. What it really needs to have is for any particular use case, like if it's for asset management or facility or for equipment maintenance, you need to say which of those classes of data do you need to meet your requirement. And I think that's where we haven't gotten as far with COBE as we need to have the exchange requirements documented to make that process easier. But maybe we'll talk a little more about that. I guess I'm out of time, but do I have any time, Steve?
We're ready to go.
What?
That's it. That's it.
I'm going to take 5 minutes. I just want to show this thing that shows how this works for energy analysis. So we did this project for GSA where we did this process map for GSA of how do they manage the energy information across their buildings, and how do you, they're going to publish all this when it's all done, but how do you, from design to operations, how do you optimize the design, how do you do schematic design, you know, this is all the standard process. So we set up this way to identify all the exchanges of information that happened. Then we took a particular building model, which was an 8-level office building with a bunch of atriums and curved surfaces and a realistic structure. And what we did was map ASHRAE 90.1, which would provide a baseline for what energy use should be, Energy Plus, which is the common way to do simulation of energy performance for buildings, Project Haystack, which is the way that you structure controls data so that you can get controls information back about energy usage. And then we used IFC to map all those things too, so that we could, from a model, be able to both predict the baseline, simulate it using Energy Plus, and then record actual data and be able to get a comparison of actual usage to projected usage. And so we went through this building, that's what it looked like. There were a bunch of space boundary issues. There were a bunch of issues with the way the equipment and the ductwork were modeled that have to be cleaned up. So we had this model that looked great, but when you wanted to try and use it for some specific analysis, it still needed a lot of work. So that's something to address in this. And the idea of defining this exchange was how we could do that so that we could get down to capturing space, occupancy, and equipment schedules, and having performance data, and then be able to relate design, baseline, and actual. And so GSA is going to then be able to go to their vendors and their contractors and say, here's our requirements, adapt your systems to provide those, and it's going to be based on the data that they need very explicitly identified. I think that's a missing link in getting results. So these are just some of the ways that you can do that. I'm not going to go through them because I don't have time. This is that workflow, kind of looking at it in a different way. And these are just the tools that Building Smart, they're available today. And I say, you know, they're all usable by someone to document exchange requirements. This is the National BIM standard, which I think is an important place to store and archive these exchanges that we need to continue to develop. Yes, standards are important. We need to change. It's kind of an oxymoron that standards are part of change, but in fact, they make change achievable. Okay, Steve, I'm done.
Good. Any questions for Roger? Do you have any time for him? Questions? Roger? Everyone got that?
Yeah, the data exists and the way to do it's there. We just have to do it. Just do it.
Just do it. All right. Thank you, Roger. Okay, so we're going to do an exercise now. So we have it in our handout.
Actually, you need to run these things.
Okay, so, yeah, we're going to do a little exercise on...
Okay, so you guys have the handout there, right?
To kind of illustrate the point that we already do a lot of this stuff, it's just how we go about it that we need to work on. And so this is, you know, from a hand-done set of drawings or from a CAD-done set of drawings, and it shows, you know, we've been going through this process of making schedules on drawings for years and doing details and assigning standard letters to those details and assigning names and values to and putting them into schedules. And you can, you know, these are just some examples of details, but of course, there isn't any good way to go back and validate that these are all unique or that there aren't duplications, and so sometimes those kind of errors can creep in, right, Kimon? And you know, here's an example of a door schedule, a room schedule, a door schedule, and so we've given all these doors names, but what we really want to be able to do is digitize all of this so that we can get away from the errors that come into, and also not just, if we do it in a spreadsheet, that's better, but we can just make errors just as easily in a spreadsheet or in a, as we can by hand. So we also need to be able to have some kind of database that gives us common lists that we can work off of to make this even better, so that we can have data that can be normalized. And these are just showing where on drawings these kind of marks would be related back. So we've been doing all of these things.
Essentially, we were already built, that was a database, that schedule was a database because there are relationships between types of doors and where they're located. And to be normalized, you don't want duplicate or errors in the duplicate numbers or missing types. So,
yeah. So here we took this out of this example, and there's a few errors in here. So take a few minutes and see if you can find the errors in the in this schedule of spaces and schedule and assignment of finishes for spaces.
You have questions about the exercise?
Are there any questions about how to do this exercise? Yes. Yeah, look on that schedule and look at the identification of spaces. Do you see any errors in that identification of spaces that would tell you that there's a problem? And do you see any errors in the finish schedule that shows you that there's a problem in the finishes schedule? Just throw them out there. Does anybody see anything in the...
Multiple space numbers. 125's twice.
Okay, 104 has been used twice.
Twice, yeah, it should be 107.
So there's a mistake in the numbering. So this database hasn't been normalized, right, Kimon? And so we have problems with the way we use the space numbers.
Do you really want carpet in the photo?
Yeah, do we really want carpet in the...
So believe it or not, this error 104 is one of the primary errors that comes up on the Kobe check, on even a perfect BIM model. There's always errors like that, or type errors like this. stuff that we've been checking for years, and we're already contracted to do that even if we're doing this by hand. So that's the point, is Kobe essentially is formalizing. We're going to check and see if you have duplicate numbers. We're going to see if you have a D that doesn't exist in the schedule, things like that. It's not going to check if a carpet, actually you could even do a check like that. You shouldn't have carpet in the toilet.
Yeah.
So it's basically a way to check, like Jonathan was talking about this morning. It's data, you can start churning through it, even in an Excel file, and check this. So a lot of people moan and groan about Kobe, but really it's not that complex, and we've been doing it for years. We already have been required to do it. To do this, to not have duplicate numbers and have the right types in the door schedules. That's, just think of it in those terms. So we could just move ahead.
Okay, I think we can move ahead. I think you all see that you got, this is a simple little chart. It gets, your eyes start glazing over before you get to it, and then all of a sudden you're finding errors that can compound over a whole big project.
Well,
So-
Steve made me go too fast, but I was trying to talk about in that analysis of the, looking at that energy model, we found it was a beautiful model. Everything fits together and looks great, but when you get down to trying to use it for a specific purpose, there were all kinds of problems. The ductwork wasn't connected. It all was represented there, but it didn't connect all the way to the equipment, and the port wasn't established, so you couldn't tell which way the flow was. So to do an energy analysis, you need to know the volume of the duct and the direction of flow. So when you get down to the level of wanting to use it for a specific purpose, the model has to really be right, and that you have to be clear about the requirements.
Good job.
Oh, thank you,
Excellent.
Steve.
Thank you.
Should I
All
sit
right.
down now?
Yeah, we can. So Kimon is our next speaker, and then we'll have a time for you to talk to all the speakers together. So welcome, Kimon.
Thank you. All right, so this is going to be about automating some of these
Is your
steps.
microphone on?
I think so.
Okay.
It's on.
All right, so Renee Tejan at the BIM forum last week had this quote: "Owners have rules for projects, but they are often written in a secret code. Only the owner," I'm sorry, this kind of ran off the screen, "only the owner or the indoctrinated understand." In other words, they're not clear rules that are understandable by everybody. And I'm going to be presenting with her next week, actually, about this topic again in Colorado Springs for a health facility conference. So VA requirements, obviously a hospital is incredibly complex, but even for a simple project, even for a small house, there's an incredible amount of data that churns through a project. And VA's managing a lot of projects like this. There are a lot of challenges, and there are a lot of opportunities. They have good data, and this is across the board what we found that every owner always has some kind of data. It's going to be in an Excel, a PDF, maybe a database, but there's information somewhere. And if they can be clear about how they can communicate their requirements to us as designers, then we can turn around and give the data back to them in a format that can be checked, like what Jonathan showed this morning. If we don't have good data, we're starting with a blank sheet. And that's really unfortunate. We shouldn't be starting with a blank slate. We should be starting somewhere. And if they give us good data, we can start with good information. So, and in that exam room, they're going to say, well, we need this type of functionality. We need to be able to do dental exams, and these are the types of equipment we think we need. They're not even sure. They're not telling you to put that equipment into it. They're saying these are the kind of things you should put into a dental exam room. Those requirements are constantly changing. So imagine a 500,000 square foot hospital or even a 50,000 square foot clinic. It's tons of data, because each of those pieces even has 10 attributes. There's literally millions of data points that have to be consumed by us as designers and given it back to the owner. So how do we break that complexity down? And we talked about it earlier. How you break complex systems down is you make them modular and easy to understand and be able to plug and play things. When you can think in terms of Legos. If you have Legos, there's minimal instructions. You can kind of figure out how to do it and put something together like an ambulance. If you have a monolithic thing that's locked and you don't know how it's built, if the wheel falls off, you essentially throw that toy away and start over again. So with Legos, if you organize things with standards like Roger talked about and Dennis talked about, then we can start getting some clear rules of how we want to build things, right? And those rules can be there could be a lot of complexity to it, but with those Lego pieces, including the equipment, if you think in terms of this as being a BIM, you can actually start setting the rules. So if in the future you as an owner decide, well, I don't really want that kind of a workstation anymore in my project. You pull it out of the Lego set, and you have the Lego sets to build with. And as a designer, then our task is to be creative and give something of value back to the owner that follows their rules, but still gives us that creativity. So it's not a rigid, locked down set of rules, but the ability to flex within that confine. So Richard talked about what's happening in the UK with the level 2 and level 3, and our view of it, this is incredibly important, and I really think this is great that this is happening in the UK, pushing the industry forward. But I also think that there are also ways, going to level 3, there are ways of thinking in terms of what's the minimum, what we call minimum viable BIM. What's the minimum data that we can use to actually start creating consistency in the, somebody's phone left here, to get to that place where we're designing with the owner's rules, for example. So I flipped the workshop around. I was going to talk for 15 minutes and then go into a workshop. I'm going to go right into a workshop because we're at the end of the day, and I'll come back with a presentation. So workshop 2D, the power of data. This is going to be the most complicated workshop of the day because your task is to wake you up. If you go to the web and search VA TIL, this is their technical information library in the Office of Construction. Incredible amount of great information about how VA puts hospitals together. There are PDF files, there are Excel files, there's probably 5,000 pages of documents that tell you how they want to put that exam room together. So you can download them and find out how to design this thing here. And you have 2 minutes to figure this out. And I want to have a Kobe file out of this, I want an ArchiCAD model, I want a Revit model, I want a SketchUp model, and I want data coming out of it in 2 minutes, right? Crazy exercise. The reason this is crazy is because this is an old way of doing things, like we talked about, going and finding files, reading through a 1,000-page document to find what does the VA want in that exam room doesn't make sense anymore. And by the way, a lot of these static documents no longer are current because they were published a year ago or 2 years ago as a static PDF. So originally I was going to have you actually fill this out on paper and everything, but let's do this together. And I want to show you the opposite way that this is happening. So I'm going to show you, and you can try, if you want, you can follow along too, you can just watch me on screen. This is a live website with US government data that's 100% public and accessible to everybody in the world. Imagine that conversation we had. This is a NIBS project, Roger was involved with this as well, where we sat down with the Department of Defense and VA and told them, you are going to open up your healthcare requirement data to the world. The reason we said you should do that is because you're already publishing it as a PDF on the web to the world. And we're not going to let you share the data that's your actual project data. Once a project is in Afghanistan, it's a different layer of security. But when your data says, this is what we want in an exam room, best healthcare practices, there's nothing secret about what goes into an exam room. In some cases, maybe. But that type of data, it took about 1.5 years with a strategic plan and everything. We actually have it accessible here. So if you're a techie, you can go, like Dennis described earlier, into the API, and it's not bus time, what type of bus is coming, it's what type of data VA uses for healthcare facilities. That's going to get a little techie. It's kind of loading up the database here. This is on the seps2bim.org website. You can try this later. You can try this right now. And I'm going to show you how this works. So if we're going to do this exercise together, help me out here. You can actually call out how many of these room types we want. So if we want to add a conference room, I type in conference, and boom, all the conference rooms show up here that are, I'm hitting their database now with their BIM data that says this is the conference room we need. So what's it called out here? Conference room CRAO2, there it is. I didn't even have to put a code there. And I'm going to add 1 or 2 conference rooms. Next one off is office. So if I search office or the code, we're all used to this kind of search, right? You start typing in code, the code letters or the name of the thing or the square footage or whatever, and starts coming up with things that are available. Now, if this owner this morning decided to change the requirements of that conference room in their database, it would actually show up here as I searched it, and it would download the right data that goes into the bin. This is real-time access to the owner's knowledge base of what they think a good hospital should be put together as. So if I go to the next here, in the shopping cart, all of a sudden I see a list of things, and I can bump this up or down, and it's recalculating the square footage down here. This is using, their names. If they change the name of that conference room, it wouldn't say reception, it wouldn't say reception, it would say waiting area or whatever. We would see it. And this data is going to make its way all the way into the BIM when we go into the next step. Yeah, there's a question.
Yeah, sorry, so with these little models of the various rooms, they are all the pieces of equipment and furniture within those rooms, are they tied back to some specifications?
Yes.
They're all, okay.
Yes, so they have a specification database. This is big data. They have a lot of data about specifications about what goes into a nurse's station.
Right.
And they spend a lot of time and effort to hire specialists to say, what should we put into this exam room? And then they put it into their database. That database used to be locked up and only accessible to people inside the VA that had to hit the print button, put a PDF file on the web for us to go look at and update it every few years, or hire AEs to come in and assemble it manually into a Word document. So if it's data, it's basically driving into the system like this. So I'm not going to type in all the rooms, but you can kind of get, and you can build them on the fly. Now this is not how they actually build up a project. I'm just giving you access to what their default standards are. In an actual project, they're actually changing how many chairs they want in the conference room. They can go into a specific project in their database, which we don't have access to. They can type in, well, in Afghanistan, we need a special kind of exam room, and we need another chair or another boom arm or whatever in their database. As that gets updated, it gets pushed into the BIM on the fly for us to download. We have a kit of parts, the Legos, that says these are the Lego pieces that we need to build this hospital. So every single output is unique, but based on the rules that are sitting underneath that, but we don't really need to be bothered with those rules because that's the background data that's happening. Any questions about this? I'm going kind of quick here. It's the end of the day, so I don't want to kind of confuse things, but yeah.
Well, if you could just clarify, so I'm designing a hospital for the VA, and I these elements, if I identify a room as a consultation room, how would then that be linked to the data that I've just imported?
Right. The VA, in VA's case, they have a program requirement that they give to their AEs coming from the system. That program requirement is coming from the same database, so it says in this consultation room, here are the things that we need. And I'll show a little bit more detail about how that gets to the architect in the end, but this is actually building a BIM in the background, which is my next step I'm going to go to. So their program...
So they just become part of a library?
They're building the library on the fly, the library and the spaces and the 500,000 square foot hospital. So you're getting 500,000 square foot of stuff that you don't have to read through the documents.
But the designer then would have to go back to the checklist and import those objects into...
No, they're in the model, and we'll go to that next.
Okay.
The model is going to get popped, the data is going to drive the model. The model is going to become a BIM if you want a BIM, or if you want an Excel file, if you want a Coding, and then you as a designer can use that as a starting point. You still have the latitude to say, well, I don't really agree with this chair in this room, or this piece of equipment is too big. You can still change it, but this is actually getting into their next contract requirements. Everything in these models has an ID, which means they can track and say, okay, we asked for this kind of chair here. You're putting this other kind of chair, and you can actually do a delta check. And that can even be done in an Excel file, or with tools like what Jonathan showed this morning. You start creating rules and says asking for clearances and whatever between pieces of equipment. So that's the idea here, is that the owner's data is driving into the model, so we as architects don't have to start from zero, and we're in alignment with what the owner wants.
Do you have a question? That answer.
No.
That answer.
Answer, okay.
So-
It's like a shortcut to a functional program, right?
I'm sorry?
It's like a shortcut template functional program.
It's a functional program, yeah. It's their first output. It doesn't mean it's going to be the final design, but it has all the pieces that they think they want for this project. Now, it's our task to confirm or change or whatever, and change does happen, which is the other part of this, because if we're constantly going through change, if you're dealing with databases and having these like spell checking type tools, model checking tools, you can start spotting the problems, because we're talking about the same language with these standards. That's why the standards are important. As soon as we start getting naming conventions in place, And this is not a very complex standard. It's not a full-blown, IFC, BIM, whatever. It's going to get to that. But this is just their stuff that they want in the building, which is a list that says, I want 5 chairs at the conference room.
So, Kimon, just a quick comment. So, it looks to me like there's this user interface that all of us are used to. It's Amazon. I'm going, I'm picking something, I'm creating my shopping cart, and yet underneath that is a whole bunch of data and a much more complexity. But at the highest level, it's just pretty simple.
It's an Amazon shopping cart. Exactly.
It's a shopping cart. Yeah.
This is BIM at the highest level. This is basically data, BIM, interfacing with somebody that doesn't know anything about BIM, but is building a BIM in the background. That's where we want to go. We want to break the complexity down to understandable pieces. And looking at this list, you probably could even look at this list and say, well, this doesn't make sense, or the square footage is too big. The reason we went through some of the exercises earlier today about the square footage is this is what VA thinks they need, 1,309 net square feet, and these are the pieces that they need. So the next step, I'm going to go ahead and put my email out, and you can actually try this. This is public on the web, so you can try it. And I'm going to say, build a BIM of these selected spaces. So what this is doing now, it's hitting their server, hitting a couple other servers for BIM, I'm not going to name what they are, and then it's building an email of this. Hopefully the internet connection will be good enough here, that I will get as an email. Yep, it's done. So I'm going to get an email here. O'clock, 3:59, just built right now. Email with a link that I can open up on an iPad or a web device here. So this is a web interface. And what this says here, let me zoom in a little bit. It tells me when this was built. There's a freshness date, because if I open this 10 days from now, it's no longer going to be the same data. It might be different. And it's building, there's that nurse's station, the square footage, there's the conference room, and the buttons on the left. I want a Kobe file. Create a Kobe file. This is a Kobe file on day 0 of the project. The reason this is significant is this Kobe has a structure of what they want, like that scheduler that Roger showed. These are the things that we call type A, B, C, D, whatever, and there's IDs associated with it. And you can take this out into SketchUp or ArchiCAD or Revit, whatever tools you want. And that is a starting point for the designer to then take off with this and start doing their work. So I'm going to download SketchUp and a Kobe. SketchUp's out. I'm going to open up SketchUp. Not to say you should be using SketchUp or not be using SketchUp. All other tools are up there too. But this is SketchUp. I'm going to go import. It's going to take a little while here. If I opened up, here's the 4:01 p.m. What this is going to do is going to go to the 3D warehouse for SketchUp and grab the right objects that are aligned with the VA. You see it's putting outlets in place right here? The reason this is taking a while is literally going out to SketchUp 3D warehouse and downloading them and putting them in the room. If we open this up in Revit, it would probably take a minute or two to load the Revit model to scale. ArchiCAD does it in seconds. Each tool has a different way of dealing with data and importing it in. So these are actually coming in, and those objects actually have the VA data that I showed earlier actually embedded in them. So SketchUp at this point is a BIM tool because it has a data with a name. I don't have to go in there and name that to be in alignment with the VA requirements.
So this is kind of design automation as well.
In a way, yes, it's a design automation of the requirements, the functional requirements that we still have to design with this. But it's automating the part. If you imagine a 500,000 square foot hospital doing this, reading through the documents, or even going through a PDF or an Excel file, it's hundreds and hundreds of hours and potential for error. But here it's an exact alignment, and it's going out to all the different tools. Does that make sense? So this is kind of...
So one point is that you're sitting on top of a well-crafted, organized database library.
Exactly, yes.
Anybody's firm here probably is doing that now in their firm with standard detail, standard whatever, or working with a client. But, thinking in those terms, you really want this to be a digital database, digital library, interactive, kept up to date. You could be the service provider doing that, if you will, but this gives a vision of what the future could be.
Exactly, and it's not a very complex database. In fact, it could be Excel, and you can actually start with an Excel file. So it's just a list of spaces. What kind of spaces do you have? 1,000 different space types. What type of equipment do you have? Here's 2,000 lists of equipment that they have in a database. They maintain that database, so when we say type 1, 2, 3, we have the same 1, 2, 3 database. If they change and they add, even if they change the size of a chair or something like that, it actually starts showing up in the database. Combining those two together, you start saying functional areas and spaces. Let's build a building. What I showed you was a generic template, but if I go back to the designer, the program manager in Afghanistan saying, well, we really need another chair there, we need a secure type, whatever. They put it into their database. It ends up in the BIM that I start working with.
So the question here.
Yes, sorry, so quickly. So when you mentioned that the BIM models are updated whenever the VA wants to.
Right.
But when you export them to Sketch, let's say, then they obviously won't automatically update.
Yes, they will.
Oh, they will?
They will. So if VA decides to add 5 other chairs to that room, the chairs will be parked in the corner. We'll have the layout, the typical layout that they hire.
The model will update.
It'll update the model, yeah. In fact, you can even
What
see.
happens if they add 50 square feet to the room?
It'll update the model. In fact, I'll show you an error that they have in their database. See that nurse's station right here? Do you think that equipment is going to fit in that nurse's station? That's their database saying this is how big a square foot we want, and this is the exact equipment we want in that nurse. There's probably a reason for that, but we caught all kinds of errors that you just would not catch in lists of things. So the designer at this point would say, well, we got this as a requirement, we're bumping that up, unless you want us to take a piece of equipment out. This happens on day one of a project, you basically start interacting at that level. So yes, if they add a new piece of equipment, we actually start seeing it happening. All of a sudden you see a chair appear out here. These are still, you can start seeing equipment. I could probably even see some here. No, there isn't any of this, but. Okay, let's move ahead. So taking that PDF and Excel route, when I said go download the files, let's go read, this is what it looks like. These are all static PDF files that do exist still on their website. You can go and read what you want. Go find a piece of equipment, go read all this stuff. It would take hundreds of hours, and then there's all kinds of errors in this because the authoritative source is not this PDF file. It's their database, because their database is kept up to date. This is a static snapshot from a year ago. So that's the exercise. We ran through that. This is the type of output. I showed you the SketchUp. There's Revit, there's ArchiCAD, there's several other tools. And the way they used to do it, this is the actual tool that we don't have access to, but we have access to the data coming out of that tool. This is internal. You have to have a login to go in and define their requirements. And the way they did it in the past, they would output a PDF or Excel file that looked nice but didn't have good data structure. Then the AE would have to read that PDF file, Excel file, and put it into the model. But now, what we guided them towards was if you get structured data and you get the IDs in there, and you go through this process that I just showed you, you can actually start populating it automatically. And that population can happen with a ton of, I mean, we've done tests with AECOM and others of doing a 500,000 square foot hospital with hundreds and thousands of rooms, literally millions of data points coming out of it. And
So what happens if you rearrange the furniture?
that's our task as a designer.
No, but if you do, and then they update the file, and it's linked, will the positioning stay the same, or?
No, that's a good question. This output that comes out here is on contract day, saying this is your contract to design this. That gets saved as a snapshot of your requirement. They might still continue, they will continue to update in the future, but this is your project that you're working with. And that's saved in the database saying on this date, you are contracted to do this. So that they no longer change things. The designer's task now is to go in and start working with this. And there are going to be changes. They're going to be back and forth, as we know in the design. They say, well, this room's too big, or we don't need that anymore. We need another department. That kind of stuff still happens. But we have the initial output that says this is our program requirement. It's a program of requirement.
But let's say you can fit the same equipment in a different proportioned room. Can you do that?
Yeah.
But then, So if it updates through the link,
It doesn't update after that. After that, the link is broken, and that's your
I see.
contract and working in Revit or whatever.
I see.
Oh, I know where I'm thinking of that. But you're really thinking about a connected world between the standards and the design, and then even after it's constructed, and you have post-occupancy, you say, hey, that really didn't work. How do I communicate that back? You really want to keep communicating back, if not for this project, for the next project, about how to improve and eliminate mistakes.
Right, exactly.
I was just gonna say, to one point, I think you'll agree with this one. What we care about is the exchange, when the exchange is made from the owner to the client, and when you send something back to them, it has to be in the right structure, but in between, you can work on it and do things that you need to do using your application tools or whatever.
It actually lets you be more sure of what you're giving back and what has changed, because they're not trying to track every single step along the way. They're saying these are our requirements, so when we give data back in that exchange, we can do a delta check with tools like what Jonathan showed, or even with an Excel file. So list the 2,000 pieces of equipment and show me where the deltas are in Excel, because Excel does that as well too. Or if you want to see the clash detection and everything, you have that as well too. So this is essentially what's happening. They have a database for rooms and department, another one for equipment. It's linked to that, so their data ends up in this model, ends up in the SketchUp or Revit that I showed earlier. And this is also an interesting concept, as we said, even if you don't, this is a minimum viable BIM concept we talked about. They're more interested in the data than the pretty geometry. The pretty geometry is important to them, but really they want to know, here are the pieces of equipment that we have. If we didn't have a pretty model of it, they show the bounding box size, so we ended up with blue boxes, or it might be a mixture of things. That's how if a new piece of equipment is added to the database, it shows up as that blue box until they replace it with a new piece of equipment in your library. So even with that, you can start working through that. And that same data, there's a subset that goes out to operations and maintenance. They typically, a lot of owners do not want the full model for operations and maintenance. They want the COBE data going into the CAFM and CMMS systems. And we're heading toward more kind of a BIM facility management. The initial value is getting the data structure back into the facility management and operations. So that's conceptually what's happening. The database goes open, models attached to it. As SEP's owner data changes, the models get updated with that, and that's on the SEP's to BIM site. And it's also linked from the VA TIL site as well. So back to the rules that Renee talked about. If owners are clear about their rules, which they already have, it's an opportunity for us to go to the owner and say, hey, we can help you design this building. We can also help you understand what your data is about, so we can be more efficient about how we work with you and give you additional value of what you want to do for that one project. And more importantly, it's really about getting it into the life cycle. How do we manage this building? Because we want to be able to loop it back around, like Steve said. Once you have that chair or that piece of exam room boom arm in a building and it's malfunctioning, you don't want to be specifying the same mistake back to a new project, which is still happening in most agencies. The loop back is not there, but as we saw this morning with WeWork, they're already doing it for their building. They're looping back that feedback from the occupants back into the initial design and changing it. So it's certainly possible to do. And it's built on this Lego type structure. And this is a very interesting dynamic that we predicted would happen. And Steve, we worked on this project together as well too, right? When we first started this with NIBS. We said, if you as an owner set the rules right, you're going to have other vendors come in and say, here's how we plug into your rules. The first one was Revit, but then all these other vendors started coming in. SketchUp with Dennis, we actually open sourced some of these tools, and SketchUp built that plugin to be able to plug into it. Then ArchiCAD came along, then BIM Object. So if you go to BIM Object, they have their libraries now aligned with VA data. BIM Object and Atania as a medical equipment company. So you have the vendors coming in and saying, here's how we provide value back and link back to that. CodeBook, TriWG is the latest one, and TriWG is a medical equipment company. So here's the type of equipment that we have that aligns with the VA objects that we see in a physical therapy room. So they're aligning their data back to the owner's data, and they're adding additional, because the VA data still is generic. It doesn't say put a TriWG equipment in there, but this company says here's our equipment that aligns with that. Okay. And there are instructions that are posted on the VA website. They're starting to make their way into the VA contracts. And AECOM did a case study with a 500,000 square foot hospital. So this is, again, a real project that they were running through to test the viability of it. And this is, again, not only just for healthcare. We have through NIDS, with a project with Roger right now, we're working with the State Department, who's very interested in looking at this process and not reinventing the wheel. Like Richard said this morning, we don't have that. We have these agencies in the U.S. that are just all over the place, but if we start figuring out how to share, there's nothing different about how you design and build space for a healthcare facility, for a house, for a school, for the State Department. It's all the same type of thing about space and equipment. And it's back to where I started this morning, that concept of shared. If we can share Department of Defense satellite systems, making them accessible to the public and even to our enemies, why can't we figure out how to share resources in the building industry to figure out how to put spaces and equipment together? I mean, there's no reason to reinvent the wheel. It's all the same. And working with the UK too, it'd be really interesting to figure out how can we collaborate on this and just get this going, because the technology is definitely there to do that. And all these agencies in the U.S. are all interested in the same thing. The DNA is exactly the same. And don't think of this as a government issue. It's higher education and other kind of clients, private sector clients, are looking at this exact same formula and using it in other use cases we have. So, last few slides. Once you have this kind of structure in place, then you can get collaboration on BIM from non-BIM users. Non-BIM users are incredibly interested in BIM data. Executives want to know, how are our buildings doing? Are we spending the money in the right place? They know nothing about Revit, nothing about IFCs and code, but they want to get to that data. If we give it to them in the right format, then they can start interacting and have meaningful discussions with them. And we, as a building industry, can give them better value. Right now, it's just completely broken. The opportunity is so huge, and I think that's the exciting thing about this session today, is that with the right people and the right minds in place, we can actually make this happen. But we have to drive it. We can't wait for the owners to tell us exactly how to do it. They all are struggling with the same thing. They all need to manage facilities. They all want to work with contractors. They all have security issues. How do we share data and keep it secure? We are State Department. We can't share everything, but we want to be able to collaborate. How do we do that right now? It's crazy how it's done today in typical agencies, because if you can't share information, how are you going to design to it? There are ways to share secure and non-secure data. That database that I just hit, there's a whole section of it that I do not have access to. It's locked in the background. They only have access to it. But I can see what they call a boom arm and exam room, and I can see how they want that in the room, and I can see mistakes that they're making and what they want in that room, because I can actually see the layout of it. So I can start interacting with that at that level. So the game changers are owners already have big data. It might be in the wrong format, but if they get it in a format that we can access, then we can build BIM to support their facilities in the life cycle. And we can start simple. It doesn't have to be complex. A lot of the BIM washing that you see out there, it's all this beauty. I mean, we love 3D, we love VR, and all that stuff. It's very important. Don't get caught in thinking that you have to start there. You can start simple and then build up. That's the lowest hanging fruit, is the simple data that's big, that spans the whole life cycle in the facility. Last slide, I was going to show this slide, I'll just talk about it. We need to start thinking in terms of how do we build open source tools. This is a Building Smart Alliance project that we initiated, thought leadership. It's an open source COBE tool that takes COBE data, uploads it to the web, creates a web service for APIs that Dennis talked about earlier. So we're essentially building that bus schedule from COBE data. I want to see what kind of assets are on that building. And these are open source tools that are being developed, and I think we're all going to start being, even though we don't think of ourselves as software developers, we have the mind of a software developer. That schedule that Roger showed essentially is a database. Room schedules and equipment and types, that's a database. That's why we're so familiar to a lot of programmers. It's basically, how do you keep data normalized and be able to share it with other stakeholders? So there's a lot more to this, but I think that's it. My voice is running out, so I think...
Excellent. So we are ready for...
Oh, one more thing, Steve, one more thing. What we did here today, these workshops, We're going to continue them on the BIM-storm, the AEC GameChangers BIM-storm. We're going to expand this to actual project-type scenarios, not just these simple exercises we did here. This is a starting point, and these are going to be free to participate in. We've been doing this for years. It's a way to collaborate and share how we do this. So if you go to bimstorm.com or AEC GameChangers, you'll see that there. And we have that volume.
Okay, so we're going to have some drawings for 2 books as our speakers for this afternoon come up, because we're going to have a final panel presentation. Whoops. I'm going to lose our... All right, so 2 books. So come on up, Dennis. We're here for afternoon. Let's see, Jeff Schuler. Where is he? What's that? Is he not here?
He might be in the morning session, perhaps.
Ah.
You missed out.
No, didn't.
You gotta be here.
Got to be here to win. Jim Panton. Good. There you go. And we have one more. Sean Yu Yi. There you go. Is that, did I mess it up? Thank you very much. Good. Okay, great. We have all our speakers here. That's really amazing. So,
Your speakers have microphones.
you're all set up. Good. All right. Do we have any initial questions for the speakers, or we will start questioning you? Go ahead.
So, I think everything is presented, especially the last one, extremely exciting to be able to have access to all that data. But what I wonder about is how will architects best benefit from that? Because there are dangers there are threats as well as opportunities with that. And one of the threats I see potentially, it could be a huge boon to architects, but it could also be a huge boon to contractors who turn to owners and say, hey, we know how to use all this database information. We can perform this service for you just as well as an architect can. And that's one potential threat, I think. And another one is those stakeholders who already are the experts, let's say in VA hospitals, may not be happy about the fact that a small 3 or 4 person office can now produce with that open source stuff, a project as efficiently as they can. So there may be pushback there. So I wonder how you address the threats as well as the opportunities.
Very insightful.
Right.
That's already
Yeah, you're exactly right on the point. There are threats and there are opportunities. If you don't step out to the plate, then it becomes a threat. The opportunities are for the ones that are willing to do something with this. And it could be as simple as guiding the owners to even understand this. We have seen pushback from firms that have worked the old way, let's say. And if we tie ourselves to how many hours we spend putting together a document, we're doomed, basically. We have to figure out how we provide more value to the owner besides hourly or square footage of documents. Phil Bernstein at Yale just assigned his class an assignment that says, as a future architect, I want you to, I forgot the exact wording, but basically he said, you have to come up with a project or a business plan that does not rely on hourly rates or percentages of the value that you give back. And you have to, if you're not fearful about that, you're going to get run over. You are going to get, as an architect, I'm fearful of that. And I think
that's already happening.
It's already happening, yeah, exactly. And if we don't, that's why the Tom Main quote is so relevant now more than ever. We have fallen behind because there are different reasons why the contractors are there first. But we also have a strength as designers. It's not simple. You can't automate everything about design. There are a lot of things that we do that definitely should be automated, And like Richard said, it's not about reducing the fees to, we have to figure out how we actually become creative about giving value back to the owner. As a small firm, I've found more opportunities starting in the early 90s with them. Because of this thinking, it actually has helped us move forward into new opportunities. And we have to think like that. And the other thing is, and you see this group here, we've actually worked with each other on these things as well, projects, but we have to think of how do we collaborate with others, including people that might be our competitors. How do we collaborate with them to create new types of value that can't be done alone?
Some other, well, that point about small firms, I think that was supposed to be one of the values of technology, that it would open up competitiveness to small firms, but I think in general it hasn't really happened, and I'm not quite sure why that is. Because
Well, technology is also supposed to, make architecture more profitable, and I'm not sure that that's happened either, but.
It's not a technology problem, it's a business
So,
problem.
but could someone answer the question about the contractors? Well, eating the architect's lunch.
Well,
Or breakfast, or making it seem fun.
I'm gonna start this one. I'm gonna set you up for this one, Kimon. There's a huge difference between having access to information and having the skills to do something intelligent, thoughtful, and useful with that information, right? The ability to make sales calls doesn't reside in having the telephone book. The ability to do something with the data that these kinds of systems make available is huge, in that people who have the skills and have something to say and something to offer aren't going to waste their time spending hours and hours and hours going through thousands of pages of documents to get that 3 pieces of information they need to do the design. Instead, they're going to focus on the design. So Kimon, where would you like to lead us from that statement?
Well, I think you're absolutely right. It's how do we use the data? If we sit back and wait and hope that it's going to come to us in a way that's going to make our life better, we have to be proactive. Look at it, see the opportunity, and step forward. Because if we don't, others will. There's certainly a vacuum in there, but it does take that skill of a designer, which I think is unique in this world as far as where we are today with automation and everything. There is that unique skill that we have that we can combine with this data and create something completely new and it's not possible.
I think the role of being the owner's consultant in the development of information and information strategies, that's a lot closer to the architect's world than the contractor's world. And the contractors have the benefit of a lot of the money flows to them because, a lot of the money on a project is goods, not services. And, and the kind of the low-hanging fruit of clash detection and all that kind of stuff, that's rightfully, at least partially that's on their side. But, again, you and I spoke about this a little bit before, but I think working with, so coming up with specialized expertise that takes advantage of information and helps owners develop strategies around the built environment and what data can do for them in all kind of ways, shapes, and forms. I think that's a consultancy problem, not a contracting problem. So I think we are in, and I think Kimon stated well. I think, you have to focus on the opportunities, not be, because the risks are there, right? I think you said it better than more eloquently than some, but I think, if you just focus on that, you are the owner's advisor for the development of these facilities and everything potentially that goes into those. Those are the kind of opportunities around information that are really, on our side of the fence as opposed to the other.
I think that if the processes are better structured, it also could take some of the friction out of identifying the real source of truth for information. So if the architect is creating a lot of information, if there's efficient ways to get that into the process, I think that is to the benefit of the architect, since that's where a lot of the information about the design is coming from. It's just not necessarily always efficient how you get at that.
Maybe there's another example, because we talk about energy, right? Energy analysis and energy environmental building, right? And I think we're all old enough to remember that when you started getting into environmental analysis, you picked up the phone and called up the mechanical engineer, right? And that was their job. and architects didn't have the capability or the competency or the access to that whole domain. I think that shifted. You still need mechanical engineers to size equipment and do the drawings, but it's not the kind of thing where we can't do a solar analysis or, you know, or an environmental study as architects. So this idea of kind of the accessibility of technology and the fact that these tools are becoming more and more accessible and more accessible to design, this is also working to our advantage, right? That we don't need, I mean, yes, you do need engineers, but the same thing is happening, that we have the capability to kind of move into those kind of domains of specialization as well. Is that
Yes, I mean, listen, you don't have to convince me. I think it's wonderful what's been shown here today, very inspiring. I'm just saying that historically what's unfolded is that others get the bigger benefit. Like, take sustainability, for example. It's now, seems to me, moving into the realm of simply being a code requirement, you know, and it doesn't differentiate architects as much from one another anymore, because
you could point to, I'm sorry.
More and more sustainability is just written into the code. It's an obligation. Many architects, Tom Mean, I think, included, would say, you know, yeah, everybody does that. I mean, that doesn't really distinguish one from another.
We're not branding ourselves now, because if all these goals by the 2030 goals, sustainability, carbon neutrality, we all talk about it, but we don't follow through into what happens with the owner at the end. We're kind of designing to it, but think in terms of if you become part of that process and follow through into the life cycle, that's an opportunity to actually make, because we're not going to get to the 2030 goals without using these type of technologies as fast as possible. And that's our challenge. That's our challenge to actually solve it.
So we have a couple questions in the back, but let me ask you a question. Is that bad, that it's becoming mainstream and a requirement as opposed to a cool
I don't think it's
idea?
bad. I'm just saying, will architects realize the benefits of it? That's all I'm asking.
That's
Okay, comment back here.
This might be a silly question, but so the data is becoming available, whether it's on the city level, cities are capturing this data, companies are capturing the data. I think the way that's the standards are getting a little bit closer in terms of how that level is being developed. But my concern has always been on the software level, let's say for BIM, that certain programs it's easy to push the data out. You know, the visual interface is pretty easy. Do you see, what would your suggestion be for the easiest way to use this data to actually create the environment? If that makes sense. I know it's kind of a nebulous question, but certain software is really easy to push back in, and certain software is made it very difficult to kind of utilize that data going the other way.
You need to ask.
We spend a lot of time on modeling, if that makes sense.
Right.
I want to get smart with it.
Like what Jonathan said this morning, we need to ask the vendors to make it as easy as possible for the data to move in and out with the standards that we talked about. And our current status quo way of doing this is exporting it from one system and importing it to the next. This is a temporary situation, I think, and just like Dennis talked about as well too. As we start getting to this connectivity, if you keep it lightweight, then you're going to be able to do these transactions. You don't have to think in terms of how do I push it from one to the next, but how do these connect and talk to each other and say, I'm designing this, what do you think from a cost perspective or an energy perspective? Not necessarily, I'm designing this, import my stuff to your thing, your tool, and do an analysis and give it back.
The way you exchange information is one thing. The information still has to be discoverable and organized in a way that you can find that. I think we are making progress on that, and if, at least like what I was trying to show with GSA, if we can express the requirements more clearly, that can make it easier for the software companies to meet them. So I think there's, and they build on, that builds on top of itself, so.
Good. So we had introduced our part one morning speakers before, but Richard was not in the room. So Richard Waterhouse is with RIBA Enterprises, but go ahead.
I was just going to respond to the previous question, which was, will architects see the benefit? It depends on your mindset. Digital disruption, which we're facing in construction now, changes roles. Typesetters don't exist anymore. They didn't stand there saying, well, we want to make sure we get something out of this new wave of digital printing. I would challenge you as an architect, I'm an architect as well, to say, what do you want out of digital disruption in construction? If you can calculate something, you can automate it. There are lots of roles in the current construction industry which are around calculation. They're the roles that are under real threat. If you create something, then you have something which is unique. That's the role of an architect. So I would look and challenge every architect in the future of construction to say, what roles which are currently using calculation do you want to now take on to expand the scope and range of services that you can offer to the clients to give them better value from your expertise? Quite frankly, if a contractor is better placed than an architect to do a job in the future, they should do the job. We don't have a right to do any role in future construction. We have to demonstrate value. When we demonstrate value, clients will pay us. That's where we've got to get to.
Okay, so I have a question for, I guess, everyone. Does this mean that we're going to, going back to your office on Monday, do you need to find some new talent in your office that's thinking more data-centric, more computerized, or, I mean, does that reside already in your firm? Or do you need to kind of augment the staff to have that as a in-house capability, or I suppose an outsourced capability? But we have examples. We mentioned WeWork, we have Shop, we have Adidas. We've got firms that are really looking at data and consultancy as an approach to things purely, and really getting a lot of business that way. But is that the sort of thing that you think maybe should transform your firm? Go ahead.
So my question would be, and I discussed during the break between the morning and afternoon with one of my people at my office, who thought that we would need to hire a BIM manager. We're not a big office, okay? So is it something that a small office can do without somebody who's real familiar with the BIM process?
Right, and that's the question you asked, Dennis. You asked who among the group already had a BIM manager as an expertise?
And it seemed like it was close to 90%, but I guess, I've worked with small firms, and I think the answer is you definitely need somebody to be paying attention to this and I think you need principal level interest, and you need somebody on your team working on this stuff. But I don't think that person has to be, that person can be a junior architect, part-time as well. So I think this does take some investment, but it's not not necessarily one FTE, exclusive investment on this. And yeah, I guess, I've watched the arc of this in professional practice, and like 15 years ago, there was nobody on the street that could do this. Like if you wanted to hire somebody, they just didn't exist, right? And now, I think, there is a community of people, we train, I teach in academia, we teach every person that goes through our program scripting, and almost everyone has to know BIM, and every one of them knows Grasshopper when they come out, and we're not unique. Every program, every student coming out of a master's program, has seen this stuff and can contribute to helping you as a member of the firm.
Ron, go ahead.
Are there any examples that you guys have come across where there's an intersection between the BIM world and where that goes, and then the IT and data analytics components that you could point to that say, in 10 years, here's where things are going to start merging together?
I think WeWork is one good example. On the government side, max.gov. Actually, that site that I showed, the SEPS to BIM, the work that I showed is hosted on max.gov. It's a government site that hosts 150,000 users. It's a place for intersecting government and the private sector, and it has a whole IT side that looks at open source tools like, certain, I forgot the name of it, but open source tools to do dashboards and linking of data and web services and using Agile.
I would say, I'll give this to Roger in a second, but I'd say, if you looked at AIA TAP's Building Information Model and Innovation Awards, and you've got Gary Technologies, you've got Morphosis, some of them that really cutting edge design, but underneath that is a lot of effort around geometry of IT, collaboration, of making things happen that what we said in our Category A awards could not have been achieved without this sort of technology.
I would say it's another space, but in the civil infrastructure area, there's a lot of move to look at big data, and they have the term civil infrastructure management. It's really more at the asset level and how assets interact with networks and the users of those networks, but that's a very big area. TRB, Transportation Research Board, there's a lot of effort around that, and in Europe, there's a lot of activity in those organizations I was talking about that are involved in that use of big data, but connecting it to assets.
So I think this is, we are a little early days in this. I think we all feel strongly this is coming, and I would say, first of all, I think every major general contractor, of a certain scale, of a national or international contractor, they have a program to figure this stuff out. They are connecting, they're trying to figure out how to connect their data systems and their scheduling and cost and all that stuff to BIM. Everyone has a program to do this. I think selectively, owners are working on this. And yeah, I think if you go to a major institutional owner, they're trying to figure out how to also connect their space management and their building controls, and you can't get too far before you say, well, we've got to use these BIM assets for something, right? And then we also had this conversation. These are being worked on by larger organizations in those two sides, and I think we talked about a couple of examples in the architecture space, and they aren't as many, but I'm a little bit familiar with what Gensler is trying to do from a kind of a client relationship and space management perspective. And they are also working on this idea that how do we use BIM data standards and facilities and space planning to be what's called sticky from project to project, right? How do we maintain a relationship with an owner by having a close association with them in terms of their overall kind of ongoing portfolio management, and BIM and data just has to be a part of that. So I think at that level, I think it is starting to impact architecture firms because they are pushing this on owners, but I think there are not as many examples in the architecture space.
And what I showed on the energy model with GSA is about that. They're taking data from tens of thousands of data points, energy usage every hour across all their buildings. They collect all of it, and they want to relate it back to the models that show how it was designed.
Question there. Yeah, going back to the small firm thing, I know that actually that most small firms do sort of high-end residential, where there are no facility manager. They don't have the same sort of COBE issues that big buildings have. They don't. So that part of the data hasn't really been relevant to sort of the high-end residential or small firms. I think that's one reason why small firms have been a bit reluctant to sort of drink the Kool-Aid of this. Just because there's a big component of it that hasn't factored in their work. But I could see actually that BIM will certainly help small businesses or small firms just in reducing errors, actually just in the coordination. Like I think that's the biggest advantage for small firms is that. Now I know that we could sort of educate our clients about life cycle costs and the advantages of sort of tracking these and sort of that. But I think that's something that just doesn't happen on the small firm level. But I think that the better coordination of drawings, fewer errors, quicker drawing production, all of that makes sense from a small business perspective.
Some advantages that we have on one-off luxury residential that they can be provided to you today with BIM without a lot of cost, that the client will notice. What if the client wants a material change and you can help them select the material that stays in their budget. What if they want to make a change to glazing, and you can tell them they're going to break code? What if they want to change the distance between where their hot water gets hotted and where it gets used? What is that going to look like in terms of how many minutes they have to wait for their shower? All of these things that are really boring for you can be done by a little robot that never gets bored and without significant cost. I mean, so on every level, these things can be useful. Question?
Hi, this is Brian from AT&T. Our real estate portfolio, Rogers, second to just GSA in scale. It's staggering. We have 240 million square feet of buildings, 65,000 properties.
And it's all in BIM?
No, that's the thing, right? And I'm an architect, been 30 plus years. Here I am in this corporate real estate portfolio. It's just staggering in scale. I've heard about facilities today, sustainability. You hear about environmental health and safety, right? There's design and construction, there's operations. You start seeing virtual reality. A mechanic can walk up to a chiller in virtual reality, and he's not pulling out paper cut sheets anymore, looking at a 2D diagram on a smartphone or his tablet. It's possibly with virtual reality and goggles when he's fixing the chiller. You tell him how to put a part together. But because of the scale we have, Tony, you and I were talking about earlier about just aspirations being folded down or cut down to objectives and eventually just action items and targets. What advice would you guys have for a portfolio of our scale? It's just so staggering. We have so much information, so much legacy systems, and then, a lot of you have been early adopters to these technologies, right? But when you have something at such a scale with so many different databases and things, where do you jump in that disruptors don't make you start over again? So like early adoption, how do you adjust with that? And I don't mean that, at the scale we have, it's a little bit different of a model to figure out, right? From early adopters to then when there is those disrupting technologies. And all of a sudden the execs say, oh, I start over again? What do you mean, there's something better now? Because not everything can mature along, an appropriate path. So.
Excellent question. So the panelists, what's the answer?
It'll always be something better, right? I mean, we can't. I'd say focus on the life cycle cost and what the big values are.
Follow the money?
Follow the money, yeah. Start there. And let me turn it back to you. I mean, are there, what keeps you guys up at night? I mean, what are the big?
Roger talked about, points energy tracking. We have millions of points. Facilities, the life cycle. Consolidating portfolio. How do we put new technologies into the new technologies? How do they fold in? How do you vet new technologies, where to place them? Because of the opportunities we have and where to put new technologies, there's a lot of decisions to make. Earlier we talked about how do you know you're making the right decision with the information you have at the time, right?
The one point that I think Kimon mentioned this is that relative to good old-fashioned system integration, like big technology consultancies coming in, charging you 100 person years for 10 years, right? A lot of this stuff, the big change about new technologies is that they can be layered on the data that you have and the systems you have. You don't have to swap those out. You can layer on these new web integration ways, and it just becomes. So I think there is one promising thing about the new technologies, which is they don't require these massive retoolings to create that added value. And that's the big lesson from FedIFM and the things that Kimon's working on.
The thing is, we have those home-built, application context and database.
Yep.
You have to
You don't have to replace it.
start with the data that you have, and you have a discussion with your IT team of how you get access to your own data. Then once you have access to your own data, then you don't have to have a BIM of everything. It's impossible to imagine. You'll get probably sold on this from several different groups, but you don't have to build BIM of everything to start using them. You start with the data that you have, California Community College is a good case study. They have 73 million square feet. They have BIM of every single building down to the room level, but it's not a full-blown detailed BIM, but it has all their spaces and it has attributes. The data that they have is fed into GIS and BIM systems, and at the same time they're having new buildings designed and delivered into that system. So you start from both ends. You don't start by saying, oh, we need to build a BIM to level of detail, whatever, this to be able to start managing facilities. That's not the case. You start with what you have, but it's an internal discussion of what systems you have in place and starting to open them up, which is exactly what happened with the SEPS work that we said. We said, we found the data, start opening it up. Now you have access to what the requirements are. And then you start from the other end, so what do you have about facilities? Then you can start linking the two together. So there are strategies. You don't have to reinvent the wheel. There's a lot of stuff that can be shared from the BIM's work.
Yeah, and it's probably helpful to do some kind of a roadmap when we're working for State Department, Kimon mentioned, and they're trying to figure out how to work with all these data from legacy systems and disparate systems. So having some kind of a roadmap that helps you prioritize and identify which uses are most critical is a good place to start. And then you find that there's common information that can be used by a lot of the pieces of that roadmap, and then you start to expose it, and then you can start to use that to meet your requirements and build on it. You don't have to do it all.
And I'd just say, I've got to believe that most of the assets that AT&T has, besides the dumb boxes, they're already web and data accessible, right? So I don't know what your portfolio represents, but a lot of it's got to be these kind of these switching systems and things like that, right? And that stuff is all already data aware and connected, right? So you already have a lot that you can start happening.
Brian, can you guess that I'm going to start by saying, don't start from the data? you guessed that, right? Start from the biggest pain in your business plan. What are the things that are keeping the organization from achieving the goals? Some of these are going to be related to facility and the operations that take place in the facility. Pick your favorite pain, pick your favorite pilot project, decide what technologies you think are going to be reasonable to deploy, and then do a proof of concept right there. And that will focus the eyes that control the money on what can be done. And after that, the big problem, now that you've pulled the wagon up to the top of the hill, you'll hit the top of it, and then your biggest problem is going to be running fast enough so that the wagon doesn't run over you on the way down, because everyone will understand. It's the understanding that's the key.
I was going to say that it fits with both of those, but one of the things we started with Kimon at DOD and then BA was, what's the plan? I mean, a strategic plan is asking the questions, and that's actually not of the IT guys, it's of your upper management. What is their perception of the problem? It may not be what anybody else thinks, but they're the ones that are controlling a lot. And then, from that, I would do a roadmap, but I would do it in a lot of iterations and these pilot studies. And if you can talk to other big portfolio of asset owners, I mean, a lot of them are your competitors, but a lot of them are others. What are they doing? I mean, I don't think you're going to find them, doing anything earth-shattering, right? I mean, do we have anybody that's got the holy grail of answers yet?
I'd say it's scattered. Everybody's working on a little piece of it, and it's fine to work on a little piece of it.
But I guess the other question is, what's the expectation of how much time this takes? I remember talking to Derek Kuntz at Mortensen when they were first doing the Disney Concert Hall and then a couple of other projects. How long has it taken Mortensen Construction to just kind of move themselves along? And they were moving just Denver and maybe Minneapolis, not the whole countries of their firms. And he said it takes 3 years. It takes 3 years to percolate through, get culture to change, get projects that make mistakes. And so what you'll see, you may see some of these firms that look like they're amazing, but they've got, they've got pockets of resistance, they've got problems they face. So I think it's a long road. I guess I'll ask the panel, what do you guys think? Is it a long road or instantaneous or?
I think if you're committed and If you're committed, 3 years doesn't sound very long to me. Yes.
I think the one thing that you can take away from this that's really positive is that construction firms are different. And during the last 7 or 8 years, had a recession and everything else, they had BIM as a process change. And they had to learn that, you go hire somebody who's quote a BIM guy. Maybe that works out, maybe that doesn't, but they have their culture inside their company that gets impacted. And they learn that BIM also requires inclusion, not to be elitist about it. They need BIM to be a cultural shift within the whole organization. You have to include your scheduling and your accountants and everybody else in it. Because they don't build anything in BIM, they just build buildings. So when you start trying to differentiate that you're changing your strategy as far as from 2D to BIM, you don't really advertise you build in 2D, because there are companies that, they think, oh, we do all 2D, but everything they seem to build is 3D. So a lot of this is they've gone through the pain. They've gone through bringing people in, they've gone through creating BIM departments. And if you watch it the last 5 or 6 years, even some of the more outspoken contractors have disbanded the BIM departments and they're just doing business. So they've kind of been on the bleeding edge a little bit. So when you look at it, you want people that come in that can be tech savvy, who have intellectual curiosity. And those people will become your stars. You don't have to change your culture. It'll just, in a 3-year window, whatever, probably is pretty accurate, it will shift. They just got to find the right place to land, and then they got to be encouraged. And training probably becomes critical. But I think if you look at the construction industry, they've taken a pretty big hit on their adoption of BIM, and now you get the benefit of watching what they did. So I really believe you're in a good spot. And at the time, the discussion about how to go about getting to where you want to go, I think that's a case-by-case event, because every company is different. So there are a lot of contractors who are doing BIM, but they're not doing 100% BIM on every single project to the same level. They're doing it all different.
Okay, we have 5 minutes left, so we get to what's the future hold? Roger.
Well, what the future
is already here.
We just don't know it yet.
Okay, go ahead.
Well, from my perspective, I think that the future revolves around continuing to build on and improve on standards for information. And that, I'm looking at it from the perspective of standards that we develop commonly and share. And that's sort of the highest level, but just making use of getting information out in a standardized way, which is some of what Kimon showed us that VA has done. It's not tied to IFC necessarily. That's the next level to me, but just getting information out, making it available, identifying how it's being used and what the uses are for it is what's really, and continuing to work together to build standards, I think is something we all need to do as an industry. We're challenged by it because of the fragmented and distributed nature of our industry. But when we look back, we're making progress. So I think we're going places and we're going to keep going.
Go ahead. I think there's a couple of critical missing little pieces that will allow all the stuff we're talking about to work in our industry. It works in every other industry. So the ability to just be able to view a bunch of this information. I showed a couple tools. I think clearly the next thing is this idea of integrating, this kind of loose integration of data together on the web, and then being able to kind of flexibly mix and match this stuff. And again, you look at other technologies, other industries, and this is what's happening already. There's just tons of stuff out there in the kind of, marketing, sales, finance communities that allow people to do the kind of things we're talking about. So I think a couple pieces, and you should see more of this in the next couple of years, having a practical application to you guys.
Before we have the last two of you, Richard, tell us the future from the UK standpoint, or the world standpoint.
Certainly for the UK and Europe, the next stage is bringing teams together and facilitating collaboration. It's about breaking down the barriers between the disciplines, breaking down the barriers between the client, the design and the construction teams. It's about linking supply chain and making sure that we can be as efficient and effective as possible in realising somebody's dream, whoever the person is that's leading that. And that can be the client, if they are a very effective client, a professional client, if they know what their expectations from any building projects are. Maybe it's a one-off client that needs expertise from the design teams. But it's got to be about having the right information at the right time, and that's what we're all working to.
Excellent, thank you. Tony? Oh, golly, the future. I think the game changer in everything we've been talking about today is that we're on the verge of being able to stumble out of the darkness and recognize that everything we need to know to make good decisions can be at our fingertips. That the information in building information, modeling or management, is there to inform decisions. And as soon as we all get on the bandwagon to turn around a lot of what we heard at the beginning of this session, I don't have the information I need to make my decisions, the decisions come in late, the information is squiffy or I don't know how to get to it, I'm not sure who's supposed to make the decision. As soon as we recognize that those don't need to be plagues because the vaccine has been talked about today, then we'll be able to make a huge stride in improving the quality and the value of the built environment without destroying the natural environment, and that's our calling.
Before Kimon's final words, Jim, share with us your thoughts.
Well, I think it's like all of the above. I think the real key is collaboration. We're seeing it more and more. It's not a dirty word anymore. I mean, collaborator used to be somebody that got shot collaborating with the enemy, right? And it was looked on that way for a while. But the standards, the integration of information, the way it flows, all of this, where it really benefits the built environment is when it helps interdisciplinary collaboration.
Okay. Come on.
I can actually work off the collaboration theme too. I think if we think big and keep it simple, we don't have to solve, it doesn't have to all be perfect like we talked about. I use the example of the internet was never complete, but we use it every day and it's constantly changing. If we don't get out there and start doing something with it and figure out where our value is in that and collaborate and figure out how we can plug in the different networks and just, if you're going to make a mistake on one side of things, make a mistake of sharing too much, not enough. If you hold back, there's a great quote from Andreas Phelps, who used to be with Alpha Brady, a great idea, life of a great idea. We'll share it. Use that to value of the industry and all over again with Facebook and all these other tools that less relevant you're going to become over time. And yes, there are going to be risks, there are going to be casualties, but hopefully nobody in this room will be part of that now that you know the secret sauce.
All right, let's give all the speakers both the morning and afternoon. A reception at the Lafayette over at Point Orlando that all of the knowledge communities are sponsoring. I thought it was really good last year in Philadelphia, but it's very interesting. So if you don't have anything else to do, it's over there, 6:30 to 8:30. I think it's $35, but I think it could be interesting. So anyway, thank you all for coming, and I hope you.
Moderator.
What's that? Thank you. Very much fun. We're doing a good job.
And thank Mark.